All right, guys, so we're going to look at number 65. I apologize for the weird pause on the last video um, because I was looking at it and I realized I'm not going to do it the way the book does it because I don't like the way the book does it. So on number 65, it says in the following exercises, given L of n or R of n is indicated, so a left summation or a right summation, express their limits as n approaches infinity as definite integrals, identifying the correct intervals. Now, I do want to go back and show you what your book has. So your book uses this formula. Where's it at? I think it was the first one. Yeah, so your book uses this formula. Now, this x of I with the little star on it, that's typically used for midpoints. So instead of just taking a left endpoint or right endpoint, they're saying use the midpoints. You can use it for any end of, any value you want to use it for. But that's what that little x of I with the star on it means. This is one way to write the definition. I actually want to show you a different way to write the definition. This definition, I've not found it in your book yet, but I'm going to write the definition like this. Let me go to the whiteboard. All right. So I want to write your definition as follows. I'm going to have the integral. It's a terrible integral symbol. The integral from B to, excuse me, B to A, there, so A to B, f of x dx. So we did have that part of the definition, but I'm going to rewrite this to be the limit as n approaches infinity of f of A plus delta xi, delta x. So we've not seen the A plus delta xi. That's new. Now it means the same thing as what we had previously. It's just this definition is going to help us do number 65 a lot easier. Now I do want to remind you here, delta x is equivalent to b minus a divided by n. So in other words, going back to what we did in the previous section, you take your upper boundary minus your lower boundary and divide by the number of intervals that you're wanting to do, or partitions would be the better choice of words there. So let me write down what number 65 says. And actually, let's do this in a different color. So 65 says, we have the limit as n approaches infinity of 1 over n times the summation of I equals 1 to n of I over n. Now, this is still wrote a little bit differently than what the definition I just gave you was. You notice how they pulled the 1 out over n out front? The 1 over n could actually have stayed in your summation. So we technically could write this statement, the limit as n approaches infinity of the summation of I equals 1 to n of I over n times 1 over n. So that's another way to do that. Guys, I'm not going to multiply it out because what happens is, looking up at my example here, I know that this delta x is 1 over n in this case. Now, this delta xi, the n just kind of hangs out. So what I'm going to do here is I'm going to kind of make a list of what we have. So I'm going to say, okay, I need f of x, that's given, and we'll talk about what it is in just a second, and a, and then delta x. Now delta x I can go ahead and fill in because I know that delta x is going to be 1 over n. Now, the f of x is a little bit hard to see because of all the n's. Really, guys, all you're doing is looking at the I. So look at the I. Are you doing something to the I? Are you squaring it? Are you cubing it? Just look at the I. So because I just have an I here, yeah, I've got divided by n, but I don't have any other operations going on with it. my f of x, that I is just represented by x. So if this had been an I over n cubed, this would have been an x cubed. If this had been an I over n squared, this would have been an x squared. If this had been an I or the log of I over n, it would have been log of x. So that's how that works. Now your a comes from whatever you're adding to your equation. So in our particular equation on number 65, there is not an addition part. So that must mean that a in my case is 0. That's the only thing I could add that would not change what we're getting here. So that's actually all I need from this equation now. So I can go through and actually solve for b, because that's the piece that I need, right? To set up my actual definite integral, I have to have an a and a b, and of course I've already got the f of x and the d of x. So now I'm going to say, to find b, I'm going to use this little definition here. So change of x, which was 1 over n, equals b minus, my a was 0, over n. I can go through, and I'm actually just going to multiply both sides by n. When I multiply both sides by n, you're going to see them cancel out. So really, you've got the statement 1 equals b minus 0. So I can say, oh, b is equal to 1. So with that in mind, I'm going to go through, and now I'm going to set up my integral, my definite integral. So I'm going to say my definite integral is from 0 to 1, right? Of my function was x dx. And that is the answer to this. Again, I'm using a different definition than what your book has, but it's going to give you the right answer every single time. And I think it's a lot easier than what your book is wanting you to do. All right, let's do another one. Let's do 67. So I'm going to clear out some of this, not all of it. I want to keep my definition up here. I'm going to clear this out, and it probably would have taken me to rewrite this thing. Okay. So number 67, they give me the limit as n approaches infinity of 3 over n times the summation of I equals 1, oops, to n of 3 plus 3i over n. So that's what we're given, guys. If you want to make it easier, you can take that 3 over n that's out front, put it in the back there so you can see your delta x. I just automatically assume that when I say that number up front, that's my delta x. So I'm going to go ahead and make a note here that my delta x is 3 over n. So that thing right there. Now notice with this one, I am adding some stuff. Let me get rid of these arrows here. I am adding some stuff to this particular problem. I'm adding 3. So this 3 is actually going to be my a. So a is equal to 3. Now I know I have the 3 times I over n. I don't care. That means nothing to me. What I do notice though is I've got an I. That I is my x value. Now notice, I know it's 3 times I. That's not going to affect my f of x. What I'm more concerned with is the fact that it's not a squared I, it's not a cubed I, it's not a root of I, it's just I. So my f of x corresponds to I, which is just x. Now, this gives me enough information to find my b. So my b is going to be equal to your delta x equals b minus a over n. So again, I'm going to multiply both sides by n. So I get 3 equals b minus 3. Add my 3, so I get b equals 6. So my final answer here is going to be the definite integral from, what was my A? 3. My B was 6. My f of x was x, and dx. So that's the answer that they are looking for there. Again, the hardest part of this, I think, is just seeing the I and making sure you don't make it like 3x instead of just what it should be, which is x. Let's do one more of those. Hopefully you've got this definition wrote down because I'm going to clear it. It's number 69. We've got the limit as n approaches infinity of 1 over n times the summation of I equals 1 to n, 1 plus I over n, log of, my goodness, this one takes longer to write than it's going to take to do the actual problem. Okay. So first thing I notice here is we've got the 1 over n out front. We're going to say that's going to be my delta x. Equals 1 over n. Now, let's talk about, I'm going to go ahead and do f of x for just a second. So that's going to make it a little bit easier for us to see A. F of x has actually got two pieces here. You've got this first piece, and then you've got this log piece. So remember, the I is represented by x. Now, I know in the first piece, we've got 1 plus I over n. I don't really care about the 1. That's going to be, because it's 1 plus in both of them, that's actually going to be A. A is 1. So really, I'm concerned with the 1 over n. That's just x. So we've got an x times, let me not put a parentheses here. We've got log of 1 plus 1 over n squared. So we're going to take the log. The 1 doesn't do anything. That's our A. That, that's part of the definition. The I over n is really x. And then we've got an exponent here, so that's going to be x squared. So my function is going to be x log of x squared. So now I'm going to solve for b. So I've got 1 over n equals b minus a, which was 1 over n. Let's multiply both sides by n to make our n's cancel out. So we get 1 equals b minus 1, add 1 to both sides, b is 2. So I can set my integral up now to be 1 to 2 of x log x squared, and then I'm going to put a dx at the end of it. We always need our dx there. So that's what the integral actually, or the definite integral is for that limit. All right, guys, hopefully that makes sense, and hopefully I'm not exactly sure what they're showing you on Newton Alta. I like this way. This makes sense to me. So let's see here. We can do some shapes now, so let's go look at that. What number do I want to do here? This is a long section. I want to do number 71. 71. So number 71 in the following exercises, evaluate the integrals of the function. Using triangles and circles and subtracting when it's below the x-axis and all that good stuff. So number 71, what I want to do is actually want to show you what the integral looks like set up, and then we're actually going to go through and calculate it. So if I was to set up my integral would look like this. It'd be the integral from, well, we're going from 0 to 12. And then it's going to be of all these pieces here. So it would be 1 minus the absolute value of x minus 1. There we go. Times 2 minus the absolute value of x minus 4 times 3 minus the absolute value of x minus 9. And that would be a dx. So that's what my integral, that's the definite integral that I'm taking. Now, if we were doing this by hand, this would be pretty nasty. Algebraically speaking, it's really nice that they give us a picture to do this. So what I notice here is, remember, the integral is just the area under the curve. Each one of these shapes is a triangle. So what I can do is I can actually use the formula area equals 1/2 base times height. So I'm pulling from geometry to do this. So I could find the area of this first triangle. So the area of, let's just do area 1 here, would be 1/2. My base is going to be 2, and my height is 1, which is going to give me a grand total here of 1. We can use different colors. Look at me getting creative here. So here on my next triangle, so we'll see triangle 2, it's going to be 1/2. My base goes from 2 to 6, so that's 4, and my height goes up to 2. So my area for my second triangle is going to be 4. And then finally, let's do our third triangle. Let's do a green here. So on my third triangle, I'm going from 6 to 12. So I'm going to have 1/2. My base in that case is going to be 6, and my height is going to be 3. So 1/2 of 6 is 3. 3 times 3 is 9. If I add all of these values up, because I want the total area under this, if I add all of these values up, 1 plus 4 plus 9 is going to give me a grand total of 14. So that's actually the integral from 0 to 12. Now, if any of these pieces had been below the x-axis, I would have subtracted them out instead of adding them. Let's do one more of those, and then I'll start a new video. I want to do number 73. So what do I want to do? No, I want to do 75. I wanted to pick something a little bit more interesting. So if I was going to take the integral, I'd say the integral from 0 to 12 of the first function plus the second function plus the third function. Now, I know you're like, well, but the second function is going to be negative. The math will work itself out. And if you'll notice, when I add it, it's actually a minus or negative square root of negative 12 plus 8x minus x squared. So it works itself out. So let's go through, instead of me writing all that down, we'll just use our stuff here. So the first one's a triangle, right? And it's a positive triangle. So I'm going to say area 1 is going to be equal to 1/2. The base, of course, here is going to be 2 times the height, which is 1. So, of course, the area for the first shape here is going to be 1. Now, let's see what you remember from geometry. This second shape is a semicircle. So area 2 is going to be, well, to find the area of a circle, remember it's pi r squared, but this isn't a full circle, this isn't a half circle. So the area is actually going to be 1/2 pi times r squared. Now my radius in this case, my diameter is 6 minus 2 is 4. So my radius is, or excuse me, my diameter is 4. So my radius is going to be 2. So it's going to be 2 squared. So that's going to end up giving me, so 1/2 of 4 is 2. This is going to be a 2 pi. And finally, let's look at our last shape. It's going to be another triangle. So the triangle is going to be, oops, area that's going to be 1/2. My base is 6. My height is 3. So 1/2 of 6 is 3. 3 times 3 is 9. Now, one of the things that I want to really make sure I put here is, even though with my pink one here, my area 2, I got a positive, it's actually supposed to be a negative. So even though when you do the math, you get positive for it, because it's underneath the x-axis, that's a negative area to us. So I'm going to make it negative. So now let's write out what we've got left here. So we have 1 minus 2 pi plus 9. That's going to be 10 minus 2 pi. And on these, I think they wanted the exact answer, so that would be the exact area of the shape. All right, cool. So I'll start up a new video here in a second, and that'll probably be the, maybe it'll be the last video I do. We'll see. See you momentarily.